Welcome back, everybody. Today we're going to talk about mean and variance for a continuous random variable. All right, so if we remember for a discrete variable, right, our mean was equal to our expected value, which equaled the sum of x times p of x. And we use this quite a bit, right? Well, the equivalent quantity for a continuous random variable is we integrate from negative infinity to infinity x times f of x. Now we got to remember that we can restrict our integral to any place where x times f of x is greater than or equal to 0. All right, so for the variance of a continuous random variable, we have yet another formula. So integral from negative infinity to infinity x minus mu squared times f of x dx. And again, we can restrict our values to where our function is defined. So we can basically say it goes from our minimum value to our maximum value. X minus mu squared times f of x dx. And a slightly more simplified formula, which would be really helpful, would be the integral from the min to the max of the x's squared times f of x. Remember, we had some dealings with that in our discrete area, minus mu squared. And this one's just a lot more simple to do. And once again, the standard deviation is the square root of the variance. So now that the formulas are written out, it's just a matter of a whole lot of practice. So let's try a few examples. Let x be a continuous random variable with a PDF of there's our f of x. 2x when 0 is less than or equal to x, less than or equal to 1, or 0 otherwise. All right, so I want you to notice that I gave you a whole bunch of formulas that said f of x, right? F of x here, f of x here, even f of x up here, all right? Well, I didn't really tell you what f of x was, but notice, right? Our f of x, or with our little f, is our PDF. So the question is very straightforward. Find e of x. right? Find our expected value. All right, I'm going to help you set it up, and then I'm going to leave you to the integral. All right, so we're going to integrate from negative infinity to infinity x times f of x. And then I want to relate it to the problem. So again, our minimum value is 0, our maximum value is 1, because that's where it's defined. And we have x times, and what is our f of x? Our f of x in this point is 2x. And I can simplify that to 2x squared dx. At this point, I want you to pause the video, and I want you to execute your integral, and we'll talk about the answer on the back end. All right, hopefully you're able to do this integral. It's pretty straightforward. It winds up being 2/3 x cubed between 0 and 1. And when you do the first fundamental theorem of calculus, we wind up with an answer not 3 on top, but 2/3. So our final answer would be that our expected value equals 2/3. All right. So again, not all of these are going to be as straightforward as this one, but the process isn't going to be any more difficult. Let's try another example. All right, so example 2. Well, make a better 2. All right, so let x be a continuous random variable with a PDF of, here's my f of x, 3x minus 4, when x is just greater than or equal to 1. All right, so it's a little bit different, or 0 otherwise. All right, so how are we going to tackle this one? Well, first I got to tell you what we're finding. We're going to find mu and our variance of x. Let's scroll up a little bit, try to keep the problem there as long as possible. So the difference is right here, right? Now I have x just greater than or equal to 1. So I need to set up my integral slightly differently. I need all values from 1 greater. So from 1 to infinity. So once again, it's x times f of x. All right, so it's x times 3x to the negative 4. All right, which again, 1 to infinity is 3x to the negative 3 power dx. And at this point, I want you to pause the video, execute your integral, and we'll talk about the answer on the back end. All right, so hopefully you were able to do this integral. When we execute the integral, I get negative 3 over 2x squared. That's between 1 and infinity, which equals 3 over negative 3 over infinity plus 3/2 is 3/2. So mu equals 3/2. All right, now to get our variance. Now to get our variance, I'm going to try to keep my mu on the screen as long as possible. To get our variance, the first thing I need is my e of my x's squared. So every time I see an x by itself, I'm going to write x squared. All right, so I go from negative infinity to infinity. Instead of x times f of x, it's going to be x squared times f of x dx. And once again, I'm only going to do where we're defined, which means I'm going to integrate from 1 to infinity. And now I want to bring my function into it. So it's x, hang on, that'll make a better x. X squared times 3 over x to the 4th. And now I want to simplify. So that's the integral from 1 to infinity of 3x to the negative 2 dx. There should have been a dx up here. I'll just squeeze that in. All right, at this point, I want you to execute your integral, and we'll talk about the answer on the back end. All right, so hopefully you were able to get this integral. When I integrate, I get negative 3x to the negative 1 between 1 and infinity. And when I execute my first fundamental theorem, I get negative 3 over infinity, which is the equivalent of 0 plus 3, and that equals 3. So now I have both halves of my formula, all right? So for my variance equals my e of the x's squared, which is 3. I'm going to write the formula again. Minus mu squared. So my mu is 3 halves. So that's going to be 9/4, and I just got 3. So 3 minus 9/4 is 3/4. And there is my variance. Again, my standard deviation would just be the square root of that. All right, let's take a look at the next one. Let x be a random variable with a PDF of, here's my PDF, so it's not big F. Remember, big F means something else, little f of x. C times x squared, where the absolute value of x less than or equal to 1. That basically means that between negative 1 and 1, that's my function, or 0 otherwise. So once again, I'm just changing up the information on you and seeing how you compensate. So I want to find a couple of things. I want to find C, which is a constant. I want to find my expected value and my variance. And then for the lastly, I want to find the probability that x is greater than or equal to 1/2. So I won't be able to keep the problem on the screen much longer, as you can see. So why don't you pause the video and write down the problem. Hopefully you've written down the problem and we can do it piece by piece. All right, so A says I want to integrate between negative infinity and infinity. And I'm just going to change my variable. So I'm going to say it's f of some function u times du. But that whole thing that I integrate has to equal 1, because anytime you integrate all the values, your probability has to add up to 1. All right, so I'm going to rewrite this because we only have certain defined values. So I'm going to go from negative 1 to 1. And now I'm going to put in my function. My function is c. Instead of x, I'm using u. So u squared du. And now we're going to integrate. So I get u cubed over 3 times c between negative 1 and 1, which equals, when I plug in 1 and negative 1, I get c over 3 plus c over 3. That equals 2/3 c. And if 2/3 c has to equal 1, then why don't you pause the video and work out what c has to equal. All right, so you should have paused the video and should have seen that c then has to equal 3/2. So now we can work with this value to wind up getting our other things. All right, so part B says I want to find my expected value, or my mu. I'm going to integrate from negative 1 to 1. And again, x times f of x, but I used u, so I'm not going to make it look like a mu. I used u, so why not keep using u? And what letter you use isn't necessarily the most important thing. It's just a matter of keeping it straight. So now my c, remember, my function originally was c times x squared. So now I'm putting in 3/2, and I got to remember that it is indeed x squared, all right? So I'm going to say, I can take my 3/2 out of my integral. It's u times u squared, which is u cubed, from negative 1 to 1. And why don't you pause the video and execute your integral, and we'll talk about the answer on the back end. All right, when you did your integral, you should have gotten an answer of 0. Now, that is not necessarily unexpected, because when you graph this, there is equal area around 0. So it is, again, a net area. So part C, we wanted to find our variance. And that equals, again, okay. So we need to find our e of x's squared. So anytime I see a u, I'm going to put in a u squared now. So I'm going to integrate from negative 1 to 1. And instead of u times f of u, it's going to be u squared times f of u. Now remember that f of u, remember, was x squared originally, so u squared. So I'm going to keep that in mind, because then I want to start putting together my function. So u squared times u squared is u to the 4th du, right? But remember, it was times that 3/2, right? 3/2. 3/2. I'm going to pull that out of the integral. And this should not be u squared. It should be u to the 4th. There we go. Now I want you, again, pause the video, do the integral, and we'll talk about it on the back end. All right, so I have 3/2, and it's going to be u to the 5th over 5 between -1 and 1, which equals 3/2. When I plug in my upper and lower limits, I get 1/5 plus 1/5, which is 3/2 times 2/5, and it's going to be 6/15, and we simplify to 3/5. So there's your variance. All right, and lastly in this problem, kind of a long one, we want to find the probability that x is greater than or equal to 1/2. So again, pull out my 3/2. I'm going to integrate between 1/2 and 1 because those are my defined values. And my function again is c times x squared, so just x squared. So I'm just going to do the integral. 3/2 x cubed over 3 between 1/2 and 1. And when I plug in my values, I get 3/2 times 1/3 minus 1/24. All right. And when you do that algebra, I wind up with 7/16. So that is my probability that x will be greater than or equal to 1/2. All right, and that brings this section to a close. And we are going to move on to section 4.4, which is the uniform distribution for continuous random variables. All right, and when you see something like this, x, right, uniform, that means x is a uniform distribution between a and b where a is less than b. All right, so let's draw this out real quick. So if I have, there's my a, there's my b. Say it goes up that high. Right? If it's uniform, it's the same all the way across. So we could say that f of x is a constant, which equals 1 over b minus a. All right, if I were to look at a graph of the CDF, cumulative distribution function, of a uniform distribution, right, and here's A, and there's B, right? It would be, I'll change the color so we can see it a little bit better. Change it to green, right? It would be 0 all the way until we got to A. And then it would be a steady rise until we got to B, which ended at 1. And then it would level off because it would stay at 1. All right, so our CDF, let me change back. Our big f of x is going to have the following values. It's going to be x minus a over b minus a, and whatever a, b, and x are, between a is less than or equal to x, which is less than or equal to b. It's going to be 1 when x is greater than or equal to b. So then this should not be there. And then it's going to be 0 when x is less than a. So there's your cumulative distribution function. And on a uniform distribution, my PDF, my little f of x, is going to equal 1 over b minus a. Hang on, make that a little bit bigger. Which is less than b, and 0 otherwise. And 0 otherwise. All right, a couple of formulas that we are going to need to know for the uniform distribution. And again, the formulas only get difficult because they are very, very localized. So my mu for the uniform distribution is still going to be the same as my expected value, which is going to be a plus b over 2. All right, which, if you remember, was also, looks like our midpoint formula from pre-calc. And for my variance, I'm still going to use my e of x's squared minus mu squared. All right, now if I plug in my a's and b's, all right, that is going to be a squared plus ab plus b squared over 3 minus mu, which mu was a plus b over 2, so it's going to be a plus b over 2, the whole thing squared. And when you do your algebra, which maybe I'll ask you to pause the video and do some algebra. Let's do some algebra, simplify this, and see what we get. All right. So hopefully we did some algebra. You got the same answer I did, which is b minus a squared over 12. So this would be my variance. All right, so here's the example we're going to do. The current measured in a piece of copper wire is known to follow a uniform distribution over the interval between 0 and 25. Write down a formula for the PDF, little f of x, for the random variable x representing the current. Calculate the mean and variance of the distribution and find the CDF. All right, so we got a couple of questions here that we need to check out. All right, so I'm going to scroll up. Pause if you need to write this down. But I'm going to scroll up. Right, and I'm going to break these questions into groups. So my first thing I'm going to answer is, what is little f of x? Now, my formula says 1 over b minus a, right, between my interval, between a is less than or equal to x, which is less than b, and 0 elsewhere. So my f of x, I'm going to simply fill in all the different things, right? From the problem, I see my interval is between 0 and 25. So it's going to be 1 over 25 minus 0, which equals 0.04. Between 0 and 25, and 0 elsewhere. So there is my PDF. Now for my expected value, that was b plus a over 2, which equals 25 plus 0 over 2, which equals 12.5. And remember, I did give you units, so please put them in. And my variance, right, was b minus a squared over 12, which would equal 25 minus 0 squared over 12. So take a minute, put this into your calculator, and then we'll see what we get. All right, hopefully by now you have put it into your calculator. I got 52.08. Now, since my numerator was squared, and that's where my units were, my units are also going to be squared. All right, so the next piece, that was piece number 2. And then the last piece asked for the CDF. Now the CDF, big F of x, is obtained when you integrate from negative infinity to infinity my little f. All right, so we are going to need 3 regions for our big F. It's going to be 0 when x is less than 0, undefined. So now when I integrate my 1 over b minus a, it's going to be the integral of 1 over 25, right? So it winds up being x over 25 between 0 and 25, and 1 when x is greater than, let me pull this up a little bit, 25. And there are the 3 pieces. That's pretty much as hard as we can make it. So I'd like to thank you for listening. This covers the next 2 sections. Watch the video more than once if you need to. Practice, do your homework. And I'll see you guys in class. Thank you. Thank you for listening.